Welcome to the next video of Unit 7. This is actually Lesson 4. We're going to be reviewing of all the things that we've learned so far. So this is going to be kind of a synopsis before your quiz that's going to be at the end of the week. And it's going to be on adding, subtracting, multiplying polynomials, as well as identifying them by their degree and how many terms there are. For example, write a linear binomial in standard form with a leading coefficient of -2. So the first thing you need to know is that it's binomial. How many spots do I need to fill? 2, right? It needs to be linear, so that means I have to have the highest degree of 1. So that means I can't have an x with more than 1 as the exponent. And I need a leading coefficient of -2. So that means the first term has to have -2 in the front. So degree 1 means I have to have x to the first in there. And the last number can be basically whatever you want. It doesn't have to be anything. I'll put -16, but it could be anything. The thing I care about the most is that there's two items, that -2's in the front, and you have x to the first power, which is degree 1. Let's go to the next example. Write a quadratic trinomial in standard form that has coefficients that are perfect squares. So trinomial, how many spots? 3 spots. Standard form that has coefficients that are perfect squares. It's quadratic, which means the degree is what? You should be testing yourself. Degree 2. So I know that the highest degree has to be degree 2, so I need an x squared here, and the leading coefficient has to be, actually all coefficients have to be perfect squares. So perfect squares are numbers like this. 2 times 2 is 4, that's a perfect square. 3 times 3 is 9, etc. You can use whatever perfect squares you want. So I'm going to use 9, 25x minus 225. If you don't know that one, it's 15 times 15. We are. So we're done with that one. Now, in this slide, this is like the end of the first video I didn't quite have time for, so I want to go over this in more detail. In order to do these problems, you basically want to know what terms we have to combine together to get the final product. So first, if I look at this 5x is being added to something else with an x in it right over here. And my answer has 8x in it. My 4x squared is being added to the 2x squared, and I get 6x squared. That one's already done for me. And finally, this blank spot is added to this -2 to get the positive 3, excuse me. So I know that 5 plus something has to get me whatever is blue here, 8. So then that something then has to be what? 3. So a 3 has to go in the blue box here, because 5 plus 3 equals 8. The other box I can set up here has to do with the red. I know that red plus -2 equals positive 3. If I solve for the blank there, what does the blank have to be? Add 2, it's 5. So 5 has to go in for the first blank. And there I'm done. Down the bottom slide, let's go through the same process. I like that strategy of just identifying the different types of things. So I have blank x's minus something equals positive 5x, right? Now over here I have constant 4 minus something, all right, and I get -9. Finally, I have the blanks x squared minus -3x squared gets 7x squared. So we have to solve a couple of equations. Let's start with the blue one. So blank minus, then there's no x's in here, has to equal, so I'm going to say minus nothing, has to equal the 5x over here. So this has to be 5, because there's no x's in here. If there were, there'd be a little x in this spot there. The next equation we want to solve involves the red stuff, and I know that 4 minus something, which I don't know, has to equal the -9. To solve for the something, I basically subtract 4, and I have negative something equals -13, right? Because I'm subtracting 4 from both sides of this. -9 minus 4 is -13. Divide by -1, and that red blank has to be positive 13. And finally, I have the green equation, and I have blank x squared minus a -3x squared gets me positive 7. So if I subtract it, that means I have blank x squared plus 3x squared equals 7x squared. So I subtract the 3x squared from both sides. Blank x squared equals 7x squared. Sorry, 4x squared. That means that blank is 4. So this is to be 4 minus negative 3 gets me positive 7. Okay, now there's 3 different ways we multiply. The first way is by distributing, and that's only when I have a monomial. This is a quadratic monomial that I must distribute to all 3 terms. 4 times 2 makes 8. X squared times x to the first makes x to the third. 4 times 5 is positive 20. X squared times x to the third makes x to the fifth. 4 times negative 12 is negative 48. No x's, so I just keep x squared. And I want to put my answer in standard form, so I need to rewrite this so that the x to the fifth is in front. 20x to the fifth plus 8x to the third minus 48x squared. And then I'm done with the first product there. On the second one, we have something that's called FOIL. I do the first times the first, right? 2 times 5 is 10. X times x is x squared. I'll do the outer. 2 times 2 is positive 4. X times no x's is just 1x. Now I'll do the inner, negative 30x. And finally the last. Oops, I want that to be blue. There you go. Negative 6 times positive 2 is negative 12. So then I combine this in standard form. 10x squared, 4 minus 30 is negative 26. X minus 12. All right. Finally, the last method we use to multiply is the lattice method. And when I have a trinomial times a trinomial, I would highly recommend this method. It does work just to distribute, but it tends to get very messy with all the multiplying you're doing. So I'm going to use x squared here, 2x, and 1 for the first trinomial, quadratic trinomial. And the second quadratic trinomial, I'm going to put up on the top 2x squared, 4x, and then 3. Now I just multiply row by column. X squared times 2x squared is 2x to the fourth. X squared times 4x is 4x to the third. 3 times x squared is 3x squared. 2 times 2, 4x to the third. 2x times 4x makes 8x squared. 2x times 3 is 6x. 1 times 2x squared, 2x squared. 1 times 4x is 4x. 1 times 3 is 3. Whew, that's a lot of stuff. So let's go ahead and highlight our like terms. So we have 4x cubed and another 4x cubed. You notice that if it's in standard form, these line up really nicely. All the x squareds are together there. All of the linear terms are here. Constant term is at the end. And I have a quadratic term right at the front. So I'm going to write it in standard form using color coding. 2x to the fourth must come first. I will combine 4x and 4x, 4x to the third and 4x to the third to make 8x to the third. Notice that the power stay the same when I add. Then I must do the 2x squared plus 8x squared, that's 10x squared, plus 3x squared is 13x to the second power. 4x plus 6x, it's going to be plus 10x, plus the 3 at the end. Now I should have used both orange and those. Those aren't like terms, and so all this together, 2x to the fourth, 8x to the third, 13x squared, 10x, plus 3. All right, let's do a couple more things here. Now here's something interesting that's going to combine what we have learned in Unit 6 and in Unit 7 so far. I'm going to multiply the polynomials. Now look, I have a square root of 2 here. Don't let that scare you. I'm going to use the same process. First times first. X times x is x squared. Outer times outer. The negative square root of 2 times x would be the negative square root of 2 times x. Notice that the x is outside of the radical. Then I do the inner product. Positive square root of 2 times x, excuse me. So remember the x is on the outside. And finally the last, which would be the square root of 2 times the square root of 2, would be the square root of 2 times 2. They both come underneath the radical. Now of course x squared is going to stay x squared. Now look, these are both x's, they're like terms. Negative square root of 2 plus positive square root of 2 would be 0, so those go away. Now this 2 times 2 is the square root of 4, which if you pull those out would just be 2. There you have it. Notice the middle term went away. That was convenient. All right, let's go to the next one. I'm going to distribute again. 3x times x. And actually, I distributed last time. I'm going to show you the box method on this one. So again, I'm going to line it up. I have the binomial times the binomial, so I have 3x and the negative square root of 5 here on the rows. And in the columns, I'm going to have x and then negative 2 times the square root of 5 in the second column. Multiply row by column, 3x times x, 3x squared. 3 times negative 2 would be, actually, and I have the square root of 5 in there too. 3 times negative 2 square roots of 5 would be negative 6 square roots of 5 times the x. That's right here. X times negative square root of 5 is negative x, negative square root of 5x, excuse me, constant first. The square root of 5 is just a number, so you can treat it like that. Finally, negative 2 times negative 1 is positive 1 square root of 5 times 5. All right, let's do it. 3x squared minus 6 square roots of 5 times x plus a negative square root of 5 times x plus 5. That's what this one is. That's just the 5 here. I have negative 6 square roots of 5 plus a negative square root of 5 would be negative 7 square roots of 5 times x plus 5. And that's my final answer in standard form. Now, just to keep your eyes trained here, the coefficients are the numbers in front. And notice they can be any I want. It just has to be a real number. So even though I have 7 square roots of 5 in that coefficient spot, it's still just fine. You're going to be okay. Let's go to the last one. R times R squared. So r times the square root of negative square root of 6 is negative square root of 6 times r plus square root of 3 times r. And then finally, negative square root of 18. R squared, and notice that these two can combine plus, and let's just do the negative square root of 6 plus the square root of 3. Those are combined together because I have to add the coefficients. Those are the coefficients together. And then square root of 18, all to 9 is going to be 3 square roots of 2. There you have it. We'll do more of those types of examples in class just to make sure that you have all the chances you want to ask questions. But make sure to watch this video before you take your quiz on Friday. That would be very helpful.